All right, so example 9, it says in the channel shown, so this is a bunch of dirt, we got a ditch dug here, we got this triangle in here. And one thing about trigonometry, which is what we're studying, is to be able to visualize triangles in nature. So a lot of times there might not be a triangle drawn. This obviously looks more like a trapezoid maybe than a triangle, but we can go from this corner over to create this triangle ABC in this picture. So as it says in the channel shown below, angle B is 114 degrees. So I'm going to put in what I know. So 114 goes there. Angle A is 31.0 degrees. We're just going to go with 31. And side BC is 28.8 feet. And what's the length of the slope AB? Now, you hear the word slope in math, you're thinking rise over run, but there's simply, this is, like if you imagine this is like a ditch or some sort of a irrigation channel, there's that side of the hill there, which would be the slope of the hill. So they're talking to find the length of this piece. That's what they're asking us to find is x. And if you take a look at the given information again, we visualized this triangle in this channel. And we can see that we're given angle, side information. That tells me the law of sines is going to be helpful to find a missing piece. Okay, so to find x, I need to know what angle C equals. So first off, if I do that, the measure of angle C is equal to 180 degrees minus the other two angles of the triangle. So minus 114 minus 31. I'm getting 35 degrees when I do it. So 35 degrees equals angle C. The figure is not drawn to scale, by the way. This picture looks like C is thinner than angle A, right?
Couldn't you also add 114 and 31 and subtract 1?
Yeah, that's what I did. I added them up to get 145 and subtracted. But again, this looks bigger than that. But again, the way the picture's described to me, the numbers are what they are. So don't assume things are bigger, smaller, whatever, based on what you're looking at. This looks shorter than that, but since 31 is the smallest angle, that should be the shortest side. This should be bigger by a little bit, even though the picture doesn't look like it. So again, don't look at a picture and say, that looks big, so therefore it must be. Or that looks small, so it must be. Let the numbers themselves determine what happens. So once I've got that figured out, I've got x over sine of 35 is going to equal 28.8 over the sine of 31. Just a basic use of the law of sines there. I could put the third side, let's say if I called this y over here, y over sine of 114, but they're not asking for that length, so I'm going to ignore it. I'm just going to use the part of the law of sines that's going to be helpful to find what I'm looking for. So this side I know, this side I want to know, so those are the two sides on top. The angles opposite those sides go on the bottom. That gives me a good proportion. My calculator knows the sine of 31 and 35. I don't. So I'm going to ask sine of 35 equals, it's 0.5736. It goes here. And sine of 31 equals 0.5150. That goes right here. So again, don't feel obligated to know the sine of every angle in existence. Your calculator knows that. But just make sure you're writing down your stuff on your paper as you work it out and your calculator's calculating things. I'm going to cross multiply now, so I'm going to get 0.5150x is going to equal the other cross product of 0.5736 times 28.8, which is 16.5197. And if 0.5150x equals anything, to find out what x equals, we're going to divide by 0.5150. And 16.5197 divided by 0.5150 is 32.08. Unit of length on BC was 28.8 feet, so this is going to be 32.08 feet. And as promised, since 35 is a bigger angle than 31, AB should be a longer side than BC. So you can see that 32.08 is slightly larger than 28.8, just as 35 is slightly larger than 31. So again, do not assume figures are drawn to scale when you look at them. Okay, instead let the numerical values figure things out for you and allow that relationship of size to happen. So smallest, smallest, bigger, bigger, biggest, biggest. Right, so you can figure that out every time you look at these triangles.